Welcome back, everyone. In this video, we're going to be working through Lab 10, Sheet 3. Let's go ahead and get started. First things first, we are going to open up a new assembly file. Okay, so if you haven't already, go ahead and download the parts. Same process as the last two. Come into our D2L portal, content section, Lab 10, and you can download these all individually and then just save them, somewhere on your computer that you can access them easily. And the first part that we are going to be grabbing is the tube. And let's go ahead and grab that. Now, just like we've done with the last couple lectures, right click on the tube in the assembly tree and go ahead and float that. And what I'm going to do is just kind of rotate this a little bit, just like that. Okay. And let's just take a look at our plane. So we've got a front plane, top plane, and right plane. So our planes are a little strange, how they're drawn here. So let's do this. So let's take our right plane of the tube, and let's go right plane of the assembly, and we can go ahead and make that. Give it a second to load up. Click the green check mark. And let's expand our assembly tree here. And then, so we don't want to do the front plane. Let's do the top plane with the front plane of the assembly. There we go. So we want to vertically orient this tube here. And then we can do the top plane of the assembly to the front plane of the part. And that gets us close enough. Go ahead and click Control-7. And we now have our tube oriented vertically on the screen. So we're going to need another tube. So let's go ahead and hold Control and just drag another tube out, just like that. And for here, let's grab our mates. Give it a moment. There we go. And now we can drill into our assembly tree again. Let's expand our tubes. And again, I am going to use the top plane of both of these tubes and mate them together. There we go. That way they're centered on each other. And then I'm going to grab this front face here and the end of this tube here. And we're going to make those coincide. Then the bottom of this tube and the bottom face of this tube, just like that. And go ahead and click the green check mark. You can give it a Control-7, and that'll get you back where you need to be. The next component we want to bring in, and actually I'm going to collapse these. Next component we want to bring in is the gusset. So when this loads up, let's grab the gusset layout. We can kind of place it just like that. And then we're going to go right here and right here. Excellent. Oh, go ahead and mate. There we go. Forgot that I wasn't already in the tool. So let's just wait for that to load for a second, and it should just default to the coincident mate. We're going to go ahead and click the green check, and then we're going to go here, the rear face of that tube to the rear edge of the gusset. Go ahead and click there, just like that, and then go to the bottom. And the bottom edge of this tube or the bottom face of this tube is fine, and we are going to make that coincident with the bottom of the gusset assembly. Just like that. Excellent. Now we can take our gusset layout and we can just go ahead and mirror that. So you can just grab it out and then mate it on the other side of this assembly. I'm just going to go ahead and mirror it. There's situations where the mirror gets kind of a little hairy, but in this instance, this is going to be just fine to mirror it across the front. Actually, let's do it on tube 1 because that's we want to control it with the part that we're mirroring it across directly. So we're going to mirror it across the top plane there, just like that. no mates necessary. And from here, let's grab our pivot cylinder. So insert components. Give it a moment. And we are going to grab the pivot cylinder. Now here we're going to need two mates. So let's go ahead and do a concentric mate from the inside of this cylinder to the inside of this cylinder. Click mate. Should automatically give us what we need, which is our concentric mate. And let's kind of just slide this out a little bit so we have access to both faces. You can just mate face, like the inside face to the outside face here. You know what I like to use though. I'm going to use the width mate just to make sure that it is perfectly centered. Maybe this, in real life, there would probably be a bushing in between here. So in real life, likely this would not just be perfectly exactly the same dimension on the inside, this width here and the width of the inside of these two gussets. So let's go ahead and go to our advanced mate, width, and our width selection is going to be here. These two inside faces, and our tab selection is going to be the outside faces of the pivot cylinder. I'm going to click the green check mark. And now we have this constrained in two directions, and we have this is able to pivot like it's supposed to. Next thing we're going to grab is the actual cylinder. So let's click the X here, insert components. And we're going to browse to our cylinder. So we're going to go into our advanced mates profile center, and we're going to select the center of this and the center of this. And because we're using two squares, it is actually going to identify that the true center of these two parts, because they're the same exact piece, it's going to constrain it exactly the way we need it. So we actually don't need another mate here. So if I try to rotate this, like if this would rotate this, if this was just a cylinder and I did a profile center to this square here, this would still be able to rotate. And in that instance, we would need to come back to our standard mates and do a concentric mate with these cylinders here and do at least two of them to make sure that it's not, we would need two of them in a profile center. If you had just one of them in a profile center, excuse me, I'm getting all confused here. One of them would be sufficient in a profile center because then we're just constraining this rotating in a circle. If it was a coincident mate, and because it would already be constrained to the center here. If it was a coincidence mate face to face, you would actually need two. It could be any two diagonally, directly across. I probably would do diagonally, is kind of how I like to do it. But in this case, the profile center is all we need and to fully constrain this component to this component. And you can see it will still pivot as it's supposed to. Next thing, let's go ahead and insert component. And now we're going to bring in our piston. So let's grab that. Give it a moment. And here we go. So now let's grab the inside of this cylinder and the outside of this cylinder here. Let's mate that, and the mate alignment is incorrect. So once it loads our mate menu here, we could just go ahead and, this is kind of in the way here, but just make sure you go ahead and grab this align. Can you move this? It will let you move it with the top bar. Go ahead and change our mate alignment just like that. And before we move forward with the mates, let's take a Control-7 for a second and then grab a section view. And if it's not already defaulting to the front plane, you can click through. If you've constrained your planes the way that, or constrained that first item the way that I showed you at the beginning of the video, you should just be able to take a nice front plane and click the green check mark. If you haven't, you may have to play around and kind of drag that slider across to get the view that we need. Now with this, we need to make sure that this cylinder or this piston stays inside the cylinder. And in order to do that, let's go ahead and grab this face and this face. We're gonna go ahead and mate those just like that. You wanna go over to your advanced mates. And this is what's called a distance mate, but it's gonna allow us to limit the distance here. So we're at about 1.5 inches. You don't have to change this here. So the maximum dimension here, let's make this 5.5. And the minimum dimension is 0.0. So what that's going to allow is it's going to allow this to be a maximum of 5.5 inches away and a minimum of 0.0 inches away. So when we go ahead and check this green box here, now it will allow that piston to slide in all the way and out all the way without going too deep or popping out this front side here. So let's just go ahead and click the green check mark. And then we can do a Control-7 to get back to kind of a baseline here, and then click at exit the section. Just kind of click the section button. And next part that we're going to bring in is the arm, but let's bring in the arm and the spoon and the bolt kind of all at the same time. So just like we did last time, let's go to Insert Component, and we're going to select all 3 of those components. So we're going to bring in the arm and the spoon and the nut here. I'm sorry, the bolt. Click open. So it looks like we have our sketches visible. So what we could do here to get rid of that, because I do not like to see those in your file. If it's visible in the assembly, it's going to be visible in the drawing. So let's go ahead and just turn off sketches so you don't see that anymore. And this face of the arm to the inside face of the gusset, let's go ahead and make that. Give it a second and green check mark. Then we're going to do a concentric mate. There we go. You can mirror or you can grab another one. I'm just going to go ahead and mirror it. So let's grab our arm. And I'm going to mirror that. Do the exact same mirror plane as we did down here. So it's going to be 2, 1, and it's going to be the top plane. There we go. Just like that. And now, so these are perfectly mirrored. So when you move one, the other one moves as well, which is cool. If you didn't do that, if you brought it back in, you would have to do some sort of, you could mate, a plane if you wanted to between these 2 items, or you could mate the top of this arm to the top of this arm. Or the end face. The end face, there's ways to do it, but because we mirrored it, we don't need to add any additional mates. They will move together. Now, next thing, let's rotate this quote spoon here, just like that. Click OK, and then we're going to go ahead and do a width mate. We're going to center this spoon in between these 2 arms. So as soon as your mate menu loads, we can go into advanced. We're going to go width. And so the width is going to be the 2 insides of these arms to the 2 outsides of the spoon. There we go. Click OK. And now we can go ahead and do a concentric mate. Still in our advanced, we got to go. So it didn't automatically update. That was kind of good to show. So it didn't automatically choose the correct mate this time. So we're going to go and click concentric and go back to standard, click concentric, click the green check mark. And there we go. So now we have our spoon that is operating with the arms, just like that. Now we're going to have to constrain, because as these arms move up and down, or we want, as this piston moves in and out, we want the arm to move up and down. So let's grab this and this, just like that. We're going to do a concentric mate. No width mate necessary here, because the cylinder is, or the piston is already constrained in the horizontal direction, this left and right direction, because it is concentric with this cylinder. So because of that, we do not need any additional mates there. And now we can see we can go all the way in, we can come all the way out. The cylinder doesn't pop out and it's operating as it should. So second to last components, we're going to need 3 of these bolts. So we're going to grab our bolt. And one thing you can do, so we brought 3 of these items in at the same time, and they didn't kind of come in the way that we wanted them to necessarily. So it's fine for our purposes here, but if you want a little bit more control over your model, how everything kind of comes in, in the order that we wanted it to come in, we can kind of just grab your arm. You can move it up and just put it below the piston. And then maybe put the spoon below the arm. And then the bolt is now the last item. Just like that. So from here, let's grab the inside of that cylinder and then the outside of the bolt. Go ahead and mate that. It's going to be concentric. There we go. And then grab the outside face of the gusset and the outside face, or the inside face of that bolt, just like that. And then X out of your mate menu, and then hold control and just drag another bolt in. Give it a second to kind of think. Hold control, grab another bolt, bring that in. And we're going to go ahead and do the same exact process here. So mate this bolt to this hole. There it is. Then this face to this face. Same thing here. And we don't even have to move from this view. This is a great view because it gives us full visibility here. So we can grab this. We do have to move it to grab the outside face there, just like that. So you might have been tempted to mate this face of this bolt to this face of this bolt. That would give you the correct result in this instance. However, it's better drafting practice to, one, mate all the mates for this bolt at the same time. So concentric and then coincident or coincident, and then move to this bolt, concentric, coincident. It's also better drafting practice than mating these 2 bolts to each other to get the, this face to this face. It's better drafting practice to mate this face directly to the arm in which you are constraining it against. So just keep that in mind. So last but not least here, and you do not have this file in the folder, we are going to need to go to McMaster-Carr, and you're going to use this for your project. I know I already talked to you a little bit about it in our most recent Zoom meeting, but we're going to go to McMaster.com, and we're going to grab a nut that matches up with that bolt to put on the other side here. So I already know what nut I need, so I'm just going to go ahead and type that in. It's 94612A106. And it's this guy right here. So I can just download the SolidWorks. And then with my part file open, or my folder open, I can just grab this from my downloads and drop it right into my part file, into my, oops, there we go, right into my folder here. And then from there, I can open it up. I can open it up and bring it into the assembly, which I'll show you in a moment. If you didn't know what nut you need, so we already know, looking right here, we know the bolt that we have. So we can type in that bolt number, 92316A924. Okay, so we have a 3/4 inch, so that's the diameter of the bolt by 6, so, and then 3/4 16, which is 3/4 inch diameter, 16 threads per inch, and it's 3 inches long, which necessarily the length doesn't necessarily matter for selecting a nut, but we need a nut that is 3/4 16. So if we go back to McMaster-Carr, grab our nuts, and in this instance, I wanted us to use a flange nut. We need a 3/4 16. So here we go. Medium strength, serrated flange lock nut, grade 5. That's fine. Let's go grab a zinc plated. So this guy right here, this would work. We can download our SolidWorks and then drag that into our folder. Once we have it in our folder, we can go ahead and insert component, browse. Here we go. We've got it right there. Now with these guys, we can go ahead and just mate face to face here. We're going to have to redo our alignment. So once the mate menu pops right up, we can just click reverse alignment, just like that. Click OK, and it'll still slide around. So go ahead and grab this edge right here. This is actually not a perfect cylinder. It's kind of tapered a little bit. So it's going to be easier to grab this edge and this edge. There we go. And that will make you concentric. So if you tried to mate it with this edge here, this face, it's not going to work. So if it doesn't work, that's why, because it's actually tapered. If we look at it from the front, you might not even be able to really see it, but there is a slight, it's not a perfectly flat component here. That's why. So let's go ahead and get a better view on it here. And we are going to bring in 2 more of those nuts. Just like that. And like this. And then we're going to repeat the same exact process here. So in this case, maybe I'll do it this way first. Make it concentric. Wait for it to load, click the green check mark. And then we're going to go face to face, make that coincident. And then we're going to go here like that. And grab, oh, wrong. If you, okay, there we go. So you can hold control and deselect. Let's go ahead and click that. It can be a little tricky. Giving us a hard time here. So let's look at it from the inside. Oh, can't. Maybe just zoom in. Sometimes it gives you it's a little tricky to select an edge like this. And if it is, just kind of play around with it a little bit, and there we go. So it's concentric. And then we need to mate face to face. Just like that. Click the green check mark. Exit out of your mates. And there we have it. And now we have our fully created. You can also add one up here if you want. I'm not going to. And now we have our correctly mated and fully defined bead breaker model. So with that, make sure to save that in your course folder, and then you can add this as sheet 3 to your PDF that you will then submit. Remember, please make sure that, so in sheet 1, we scaled it, so it was 1 to 3. Sheets 2 and 3, I'm going to let you have control over what you scale it at, but make sure it's not overlapping the page, and make sure that it is not very small. Kind of use the space intelligently. Think about maybe if you had an instruction packet or something like that for an item, how would that be positioned on the page? So I'm going to go ahead and save this as lab 10 3 WRM, and then you can go ahead and insert it after it's saved. And with that, once you have all three of those plotted, that is it for Lab 10, and I will see you all in the next video.